Okay, so this is the video lecture for Math 3 Unit 2 Worksheet 4, and we're going to be working on factoring and solving quadratic equations. So for the factoring component, there are three different types of factoring we're going to be doing. So we have greatest common factor, so GCF, that's like an abbreviation for that, difference of squares, and trinomial factoring. So those are the three styles that we will be working with. So our greatest common factor component, that is where you're looking at, you can have as many terms as possible, but all of the terms are divisible by the same thing. So if we look here at the 3 and the 18, for example, they are both divisible by 3, right? But if you look over here, so like say 2, 11, and 5, they don't have a common factor other than 1, right? So this would not be GCF. So if I look over here, I can see that both of these are divisible by 3. So I can divide a 3 out of this one and also this one, right? And then if I look at my variable component, so I have x squared, so that means I have x times x, and then an x here. So they're also both divisible by x. So I can divide both of those evenly by 3x. So when I divide that out, okay, so when I divide both of them by 3x, then 3 divided by 3 is 1, so that would be a 1 here. And then x squared divided by x is x, right? So I have two of them here, so 1 cancels there. And then I have that subtraction symbol. And then 18 divided by 3 is 6, and then x divided by itself is just 1 or cancels. So when I divide out my 3x, I would get 1x minus 6. But remember, we are factoring. So what we're looking at are the factors that create the same thing. So I would have my common factor, which was 3x. And then when I divided it, I have 1x, which is just the same as x, and then x minus 6. So these are the two factors that when I distribute or multiply, I would get this right here. Okay, so then that would be my factoring, okay? So this would be, again, this is my GCF is what goes here, right, what I divided out. And then the remaining portion is right here, okay, so after I divided. And I can always check it through distributing, right? So I could check it by distributing, meaning I can multiply 3x times itself, which gives me 3x squared, which is right there. And then 3x times negative 6, if I distribute to there, that gives me negative 18x, which was there. Okay. All right, so then the other GCF that I have, so this one sometimes is kind of confusing to students because it has like this grouping component. But the way I need to look at it is this section right here is one item, like the 3x squared is one item, right? So is the x and x minus 1, so one term. And then over here I have 4 and x minus 1. So that also is one separate term, just like the 18x is one separate term. So this is term 1 and term 2, okay? So again, I'm looking to see what can I divide out of both of these. So first look at the front. So I have x and 4. Nothing divides out of both of those. And then over here, they both have an x minus 1, so that means I can divide by x minus 1, right? So I can divide by x minus 1. So x minus 1 is my GCF. So then when I do that division, what will I have left? Okay. So here, x minus 1 divided by itself, that just cancels to 1, so then I'm left with 1x or x. And then over here, x minus 1 divided by itself also cancels, leaving me with just that plus 4. So my greatest common factor was x minus 1, so what I divided out, and then my remaining term is x plus 4. So again, we want our factors, so our factors are my common factor, which was x minus 1, and then my remaining factor, which is x plus 4. Okay, so again, one more time, so this whole thing right here, this was my GCF, right, what I got when I divided, or excuse me, what I divided out, and then this is my remaining terms of what was left after I divided. Okay, all right, so then, and so this would be my answer right here, so I would just box that. Okay, so then now let's go ahead and take a look at the other style of factoring that you worked on is difference of squares, so difference of squares. So difference meaning it has to be a subtraction problem, right? So you're looking for a subtraction, and so these both have a subtraction in it, so that is a good first step. And then they have to be perfect squares. So perfect squares, remember, are numbers that you can multiply by itself, right, to get a value. So like 3 times 3 is 9, so that would be a square number. So 9 is a square number. But say like you get 7, that would not be a square number because nothing, no integer times itself will give you 7, right? So 7 times 1, but 7 and 1 are not the same number. Okay, and so it has to be a square number, so something squared that would generate it, okay? So x squared is a square number, right? So x squared would be x times x. And then for 9, can I multiply two things together to give me 9? And I can. That would be 3 times 3, right? But it does need to be negative 9, so that means one of the 3's has to be positive, right? And one of them has to be negative, okay? Oops, that's, squeeze my minus in there. So then my difference of square factor, so x squared would be x times x, and then for my negative 9, I need a positive 3 and a negative 3. And so those would be my factors. And again, I could check it, right? Check it through distributing. So these are called conjugates. I don't know if you learned that word last year, but these are conjugates, meaning you have like the same terms, but one is addition and one is subtraction. Okay, but anywho, all right, so then if I check through distributing, I would again multiply x by itself, so that would give me x squared. And then x times the negative 3 would be negative 3x. So again, I'm just checking. And then 3 times x would be 3x. And then finally, 3 times negative 3 would be negative 9. And then this would cancel because they're opposites, and so x squared and negative 9 is what I have there. Okay. All right, so let's check the next one. So 25x squared minus 4. So again, it's a subtraction problem, so that's always a good sign. So then now I'm thinking of, can I break that up into two terms that are the same, right? So what times what will give me 25x squared. So that would be 5x times itself. All right, and it always needs to be the same, right? Otherwise, you're not doing the difference of square factoring, right? So you couldn't do like 1x and 25x, right? Otherwise, it's not a difference of squares. And then over here for negative 4, so that would be 2 times 2, right? 2 times 2 is 4. So that's a square number. And then you need one addition and one subtraction, right? One positive, one negative. Otherwise, you won't get a negative 4. So then when you go to factor, so you're going to set up your binomial, your groupings, and so 5x times itself, so those go in the front, and then positive 2, negative 2, and that would be your difference of squares. Okay. And then again, you could check it through distributing to verify that. So you might want to press pause and like distribute that out and see if you get the same thing there. Okay. All right, so then now for trinomial factoring, so this one right here. So this one, sometimes people call it also guess and check, so you might have heard of that. So guess and check or trinomial factoring. And so that like tricycle, so that means you would have 3 terms. And that typically is the clue, oh, I have 3 terms, I should probably do trinomial factoring. So people teach this different ways, so I tend to do what I call guess and check, so guess and check. So the first thing that we do is we just list our factors for 2x squared, so I do like a little t-chart there. But again, lots of different ways to do it. So for 2x squared, so what multiplies to 2x squared? So that would be 2x times 1x, and that's the only possibility, right? So 2x times 1x. And then what are factors that multiply to 5? So that would be 1 times 5. Or I could use negative 1 and negative 5 as well, right? A double negative. So maybe negative 1 and negative 5 as a possibility, right? So 2 positives or 2 negatives. But I know by looking at this guy right here, see how that's positive, that it's not going to be that one. Okay, so that means it has to be the middle term. Okay, so once I do my guess and check, so this one is a pretty nice one to set up. So this one right here, so I know I'm going to have my grouping symbols like that. And so I'm going to be thinking about how am I going to create that 11x in the distributive property component. So I know for sure it has to be 2x and x, and I know for sure that it has to be positive 1 and positive 5, because that's the only way to get a positive 5 when you multiply, and keep that positive as well. So I'm going to just randomly put, so let's say this is plus 1 and this is plus 5, right? So if I were to check this, I would have 2x squared, which, yay, that's good. And then here I would get 2x times 5, which is 10x, right? So that would give me that 10x value. And then I would get a 1x here, and then 1 times 5, which is 5, which is that guy there. So did this also give me the 11x? And it did. So then this adds to 11x, so then I know this is the correct factor. Okay, so that would be my correct factoring. So what would it look like if I had it flipped around? Like maybe I'm putting them in a different spot. Okay, so I'm going to go ahead and do this one the reverse way, just so you can see like if that was in the wrong spot, like what would that look like. So let me just erase this here. So what if, so what I'm saying is, what if the 5 and the 1 I had in the other location? So if I had the 5 first and the 1 last. Okay, so I'm still using 2x and x, right? Here, 2x and x, and I'm still using 1 and 5. I just have it flipped around. So when I went to go check it, I would say, okay, 2x times itself gives me the 2x squared, which is what I'm hoping for. And then 2x times 1, and then 5 times x, and then 5 times 1 gives me that 5. But these guys add up to 7x, which is not what I wanted here, right? I wanted an 11x. And so that's how I know that this one would be wrong, right? So it's not called flat out. Just guess what it is. You need to guess and then check it. And you're going to check it through distributing, okay? So remember, this is called guess and check. Guess and check. Okay. So let me undo my wrong version. Okay. So let's go and take a look at the next one. So factors for 3x squared. So I have the only possibility there is 3x and x, right? There is not another possibility. And then for the negative 10, it could be 1 and 10 or 2 and 5. And then one of these numbers has to be negative, right? So that's the only way to get a negative 10 when I multiply. So I don't know what needs to be negative, and I'm not going to know until I get my factors started, right, in terms of that guess and then check component. All right, so I know for sure it has to be 3x and x, right? That's a for sure thing. But I don't know if it's 1 and 10 or 2 and 5. So I'm just going to try 1 and 10 just to get started. And so if I distribute, I'm going to get 3x squared, excellent. And then here I'm going to get 30x and 1x, and then of course the 10. So is there any way to combine 30x and 1x, keeping in mind that one of these has to be negative, to give me a positive 1x, right? Because this is the guy, this is what I'm looking for, right? Is I'm looking for that kind of positive x. So if I look at that, there's no way, right? Because that's either going to add up to 31 or subtract to some form of 29. So I know 1 and 10 like that is not going to work. So I know that's not right. And I'm going to go through all the wrong ways. So then now I'm going to flip it and call it 10 here and 1 there. Okay. So then I'm just going to check those middle terms. So I have that 3x times 1 and 10 x there. And then is there any way for me to combine 10x and 3x to get 1x? So that's either 13 if I add or 7 if I subtract. And again, I'm trying to get 1x. So I know that's not right either, right? So I've tried all the possibilities for 10 and 1, so I know that's not going to work. So 10x, or 10 and 1 is a bust. So now I'm going to try 2 and 5, so 2 and 5. Okay, so let's say that's the 2 and that's the 5. So hopefully you figured out now you don't need to do 3x times x to check your first and last terms, and 2 times 5 because they came out of this section here. So those have to be right first and last. It's just the middle term you're checking. So I'm just going to keep working with the middle term. So 2 times x, 3x times 5, and I look to see, can I combine these by adding or subtracting to give me 1x? And I can't, right? So that won't work. So then my very last, so I did 2 5s, so now I'm going to try 5 2. So hopefully you start strategizing those, so you don't have to check like every combination. Like you start thinking about like, will it work or not work? And so it's important for you to realize that like this is not something that is just going to be like naturally intuitive to you initially. Like you're going to have to like put in some work and come up with your own thoughts and strategies so that you can solve these easier. Or maybe not easier, but more efficiently, I guess. Okay, so let's go ahead and check here. So I have a 5x and I have a 6x, and I want to combine these, right, to get 1x. So if I add them, I'll get 11x, but if I subtract them, I will get 1x. And I know I need to subtract because that's negative, right? Because one of these numbers had to be negative. So I want the 5x to be negative because I want to do 6x minus 5x to get a positive 1x. So if 5x is negative, there's the negative there and the positive there. Okay? All right, so that was a lot. Okay, so let's go ahead and take a look at what we're really doing, which is solve by factoring. I've got like pencil eraser dust everywhere. Let me clean up a little bit. Okay. All right, so let's take a look at solve by factoring. So what you may want to do right now is press pause and kind of look at this worked out example to see like, you know, how much do you remember from last year? Or actually, I guess Math 1 would probably have done some solving here. Math 2 would have incorporated the quadratic component. So maybe press pause, try to look at the worked out example and see what you remember. Okay. So if we are solving by factoring, then there are certain things that we always want to make sure that we have. We always want to make sure our equation is equal to 0. So if it does not start out equal to 0, we need to make sure that happens. And typically we want, you know, the variables on the left, but it doesn't have to be, okay? And then once we equal it to 0, we're going to factor, and we can use any of the factoring styles that we had above, okay? So that's always our first step. And then we want to use our, what we call the zero product property, meaning that if I have two factors equal to 0, the only way that is a possibility is if either the first factor is 0 or the second factor is 0, and those would be our solutions. And so that's what we call the zero product property, and so we just set each factor, so that should have said set each factor equal to 0. I don't know why it says equation. So just percent it says set each factor equal to 0. Okay, so and then we solve, then once we create that new equation, then we solve each equation separately, okay? All right, so let's take a look here. Okay, so if I look the difference between step 1 and step 2, so what is different? So if I look between these two steps here, it looks like then this turned into a 0, right? So 18 turned into 0, and that was done by subtracting the 18 over, right? So first things first, subtract the 18 over. And then factored, so then this is a trinomial factoring, so that would be like our guess and check factoring, like this style over here. So this was our next step was to factor, and so that's what happened here. And then I set each factor, so each factor separate, equal to 0. So the 3x minus 2 equal to 0, and then the x plus 9 also equal to 0. And then each one of these was solved. So if I subtract 9, I got x equals negative 9. Here if I add 2, and then divide it by 3, and then I got x equals 2/3. Okay? All right, so solve by factoring. Okay, so remember, equal it to 0, factor it, set each factor equal to 0, and then solve each equation, each new equation. Okay, so let's start with question number 1. So if you think you got that just by talking through that, then you should press pause and try to do 1, 2, and 3, and then hit play, fast forward, and then just check your answers against mine. Okay. All right, so for question number 1, so step 1, equal it to 0, so I'm going to subtract 3 from both sides. And then from there, I want to factor. So I know I have trinomial factoring because I have 3 terms here. So I am going to do guess and check. So I'm going to do my factors of 8x squared. So x times 8x, 2x times 4x. And then my factors of 3 are 1 and 3, keeping in mind that one of those needs to be negative. Okay. So I am going to just kind of work from here to see if I can get a 2x or close to that before I do my guess and check. So I know if I multiply these together, I'll get a 1x, so 1 times x, and then 8x times 3 is a 24x. So I have a 1x and a 24x. I'm thinking that in my brain. That's nowhere near 2x, so that doesn't look good. Or if I go the other way, so if that's 8x and 3x, so 8x and 3x also won't do that, right? So then I know I'm not even going to try that guy there. So then I'm going to have 2x and 4x. And then, let me not steal all the space over there. So I'll have 2x and 4x. So like that. Okay. And then from there, I know I need to use a 1 and a 3. And again, one of them needs to be negative because when it multiplies together, it's supposed to be a negative 3 here. So if I have, say, a 3 and a 1 here, so that will give me, so I'm writing lightly here because I know I'm going to erase, so that would be 12x, and then here will give me 2x. And then 12 and 2 won't combine to give me 2, right? Because that will either add to 14 or subtract to 10. So then I'm just going to switch this around to 1 and 3. And so if I multiply those together, I'll get 4x, and then those together, I'll get 6x. And then I want this to add up to 2x, right? And so if I just add both positive, that gives me 10x, which is no good, right? But even more importantly, one of them has to be negative, right? Because of the negative 3 here. So I want a positive 2x, so that means I want the 4x negative. So then that should be the negative, that should be the positive, right? So if I were to distribute this to check it, 2x times 4x is 8x squared, 2x times 3 is 6x, this guy right here. Negative 1 times 4x is negative 4x. That combines to give me my middle term of 2x, and then negative 1 times 3 gives me my negative 3. Okay. And then once I do that, so that was just my check part, so I'm going to erase. Okay. Then I'm going to split into 2 equations and solve these separate from each other. So I'm going to take 2x minus 1, that factor, equal to 0, and I can do that because of 0 product property. And then 4x plus 3 equal to 0. Now remember, don't forget it's called the 0 product property, so it should always be equal to 0, right? And then just solve like you normally would. So I would add 1 to both sides. And then divide by 2. So x would equal 1/2. Okay. And then do the same for the other side. So again, this might be a good time to press pause and then solve that one and then forward to see if you got the same answer. So I would subtract 3. And then divide by 4. So x could either equal negative 3/4 or 1/2. And both of those would be solutions to this equation up here. Okay. All right, and then let's take a look at number 2. So the first thing we always want to do, remember, is we always want to make sure that it's equal to 0. So right now it's not equal to 0, it's equal to 16x. So I want to subtract the 16x from both sides. And these can't combine, right, because the squared here but not there. So I have 2 terms here, so it's not going to be trinomial or guess and check because that would be 3 terms, right? So if I look at difference of squares, like I can do 4 times 4 for 16, but nothing times itself for x, and then nothing times itself to give me 8. So then now it must be GCF, right, common factor. So for GCF, I look to see what can I divide both of these by. So I can divide 8 and 16 both by an 8. And then for x squared and x, I can divide both by x, right? So they're both divisible by 8x. So when I write my factors, remember, we want to do factors, so plural. So what did I divide out? So what was my common factor? So I divided out an 8x, and then what is remaining, right? What is remaining? So what is remaining? So 8 divided by 8 is 1, and then x squared divided by x is x. So this would be 1x, which is just the same as x. And now minus, and now divide these guys. So 16 divided by 8 is 2, and then those cancel. So then now I want to do zero product property. So zero product property, and I can do that because it's equal to 0, right? So if it was not equal to 0, I could not do zero product property. So then for here, so I'm going to take each factor and then equal them to 0. So I have 8x equal to 0 and x minus 2 equal to 0. And then I just solve each of those equations. So here I have 8 times x, so divide both sides by 8. So that cancels. And so I have 0 divided by 8, which is 0. And then on this one here, add 2 to both sides. And so then I would get x equals 2. So then my solutions would be 0 and 2. All right, and then the last example on this side. So right here, so for this one right here, so again it has to be equal to 0. So right now it's equal to 3, right? Equal to 3. So I would subtract 3 from both sides, but when I do that, I don't have anything to subtract it from because this is grouped, right? So I need to not have it be grouped. I need it to look more like, you know, these where it's like already like distributed, factored out before I equal it to 0. So because when I subtract 3 again, like if I try to, there's nothing to subtract it from because these are grouped. So then that's not what I want to do first. I want to distribute. Okay, so I need to distribute. Whoops. There's my pen flying. Okay. All right, so for here, so I want to distribute. So I'm going to multiply x to the 2x. So that gives me 2x squared. But the x also has to multiply the negative 1, right? So this has to multiply to both of those over there. So that would give me negative 1x. And then I would multiply the 2 with both terms over here as well. So 2 times 2x. And then finally 2 times negative 1, so that would be negative 2, and then still equal to 3. So then now I can go ahead and equal to 0. So now I'm going to go ahead and subtract 3 from both sides, and now I have something to subtract it from. And at the same time, I'm going to go ahead and combine these guys right here as well, because they're both x terms. So I'm left with a 2x squared, and then negative 1x plus 4x. Negative 2 and negative 3, and then that would just be 0. Okay. All right, so now that it's equal to 0, remember that's always step 1, set the equation equal to 0. Then now I can go ahead and factor this, and when I factor it, it's trinomial, so I'm going to do guess and check. So you may want to press pause here and then see what you can do, right? See what you can come up with to get your factors. So you go ahead and give it a shot and see what you can come up with. Okay, so for 2x squared, so my only factors are 2x and 1x, and then for 5, my only factors are 5 and 1, or 1 and 5, of course. And then again, one of them has to be negative because you have that subtraction right there. Okay. So I know it has to be 2x and x, and what I don't know is where does the 5 go, where does the 1 go? So if I try the 5 here and the 1 here, so let's give that a whirl. So that would give me 5x there, and then multiply those gives me 2x. And if I add them, I'll get 7, but I'm looking to get 3. So if I subtract them, I will get 3. So 5 minus 2 is 3. And I should be subtracting again because one of them needs to be negative here, right? So which one? So the negative 2x. So when I multiply these two together, so that should be negative, and that one should be positive, right? So that would be positive 5x and negative 2x. All right, and so now that it is factored equal to 0, I can use the zero product property. So you guys can, again, press pause, try to do that, and then forward to see if you got the same thing. Okay, so I'm going to make two equations here. So each factor is going to be equal to 0. And then solve that. So then I'm going to subtract 5. So I will get 2x equals negative 5. And then divide by 2. And then on this side here, I'm going to add 1. So then my two answers are negative 5/2 and 1. And there you go. Okay? All right, and then let's take a look at the back side. Okay, so this one, so zoom out just a little bit here. Okay, so what we have to do is we're going to be solving, instead of by factoring, by what we call square rooting. And so just a few reviews. So we need to know our perfect squares, or be prepared for that. Okay, so like for example, the square root of 1 is 1, square root of 4 is 2, and then so on down the line. And then the other thing that is important, whenever we square root something squared, we always get the absolute value of x. So like the square root of 16, so even though negative 4 times negative 4 also gives you 16, we use what's called the principal root, and that's why this is 4. Okay, that's why that's 4. Okay, so, but of a variable, right, so square root of x squared, the variable would be the absolute value of x, right? Because you can't just write x because you don't know if that's positive or negative, so you have to put the absolute value around that. Okay, and then for non-perfect squares, you can do this different ways. So people sometimes do factor trees, some people do roots, you know, with perfect squares, however you want to do that. So I'm going to do it with a factor similar to our guess and check style. So for example, like 8 could be 1 times 8 or 2 times 4, right? Only possibility. But I have to be able to square root one of them. And so 1 times 8, like using that is not helpful, right? Because like you're not breaking anything down. So we'll not ever use 1 times something, okay? So we're never going to use that one. So the only other factors for 8 are 2 times 4. And so the way I look at that then is the square root of 8 is the same thing as the square root of 2 times the square root of 4, right? Because 2 times 4 is 8. So I don't know the square root of 2, but I do know the square root of 4. Okay, so then this would be the square root of 2, and then the square root of 4, which is just 2. So normally, though, we would not write it this way, and a lot of that has to do with just like notation, like we don't want to put that dot there. So we always want that integer value first, and then the irrational number second. Okay, so that's typically how we would write that. So 2 square root of 2. Okay. All right, and then square root of 12. So again, 1 times 12, right? Or we could do 2 times 6 or 3 times 4. So of these pairs of factors, which one do we know the root of? And it's 3 times 4, right? So then I'm going to take what the square root of 3 and then the square root of 4. And I'm doing that because this is still square rooted, right? So I know I have root 3 times root 4. 3 times 4 is 12. So I don't know the square root of 3, but I do know the square root of 4. And so then that would just be 2 root 3, putting it in the right order. Okay? All right, and then, so that's one way, right? So just knowing your squares. The other way is the factor tree, right? So I'm going to show you factor tree as well, just in case that's easier for you. So for 75, that's 3 times 25. And then 25 breaks down, this was the factor tree method, to 5 times 5. And then, so I broke that down, so I'm going to cross it off so I don't use it again. And so then now my factors are 3, 5, and 5. So then you take your pair, so your pair is right here. And so your pair goes outside, and the one that does not have the pair goes inside, right? So something like that. So that was another way that you might have learned, is the factor tree method, looking for pairs. So 18, for example, is 3 times 6, and then 6 is 2 times 3. So I just broke down 6, so I'm going to kind of scribble that out so I don't use it. And then I look for pairs, so I have a pair of 3s, pair on the outside, and the non-pair on the inside. Okay. All right, so two different ways, right? So you have factor tree method, and then you have just listing your factors over here, and then just working with the roots that way. Okay? All right, so that's a little review there. Okay, so last style here. So solve by using square roots. So solve by using square roots. Okay. Okay, so for this method here, you are going to know, okay, when do I solve by square roots? And you know you're going to solve by using square roots when you only have one x in the entire equation. So when you scan, whoop, 1x. So solve by square roots. Versus on this page, if you look, there's x's everywhere, right? So couple x's, couple x's, couple x's, right? So I know that for this method, equal it to 0, solve by factoring. So x's, multiple x's throughout the equation. This one right here, solve by using square roots, I know how to use this method because there's only one x in the whole problem. So if I look down here, for example, how many x's do you see? Just one, boop, right there. How many x's do you see right here? Boop, just one right there, right? So solve by square rooting, that's when I know to use this method. Okay. All right, so what is the first thing I do? First thing I do is I isolate the squared term, okay? Isolate the squared term. So if I look here, what's being squared? All of that, right? So that's what I need to isolate. So that means I need to get rid of the 3, get rid of the 4. So I would get rid of the 4 first, right? So subtract 4. So then that canceled. So see how that's missing over here? And then 13 minus 4 is 9. So I'm still working on step 1 though, right? Because I'm not done because I have that 3. So I'm going to divide by 3. That cancels, so that's why that's just there. And then 9 divided by 3 is 3. Okay. All right, so that's my first step, isolate. And then step 2 is I want to square root both sides, keeping in mind that when I square root, I have absolute value, right? So square root, I have absolute value. And then from our earlier objectives, we worked on solving absolute value equations, okay? And so we'll review that as well. Okay, so for right here, so then I know that step 2 is to square root both sides, so square root here, square root here. So I don't know the square root of 3, so that's why it's still there. But whenever I square root a squared, it needs to be absolute value, right? It needs to be absolute value. And then from there, I would create 2 equations, one positive and then one negative. So I would have x minus 1 is equal to root 3. And then technically this would be negative, right? But what did we do every time we divided that negative over? So we're going to start skipping that step of dividing it over, and we're just going to automatically just divide it over right off the bat, okay? And then now we solve this absolute value equation, so I would add 1 to both sides. And then here I cannot add these together because that is an integer and this is irrational. So I can't make this a 4. I have to write it just side by side. And again, standard form, okay, not because you have to, but standard form is you put your integer first and your radical second. So that's why the plus 1 and then the root 3 is positive as well. You don't need to put a plus here though, right? So 1 plus root 3. And then right here you would add 1 to both sides here. And then this cancels, and so then you would have x equals, and again you're going to put the positive 1 first and then the negative root 3 second. And then a shortcut way to write it is just to write 1 plus or minus root 3 because they're the same, just 1 adding 1 subtracting. Remember this is called conjugate, so conjugates. So then that's what you could do there. Okay, so let's go ahead and solve for both of these. Okay, so step 1, isolate the squared term. So if I look here, so what am I trying to isolate? So I'm trying to get this by itself. Okay. So in order to get that by itself, I need to get the 3 over. So I'm going to divide both sides by 3. And then I will have x plus 2 squared and then equal to 8. And then this is by itself, so now step 2 is to square root both sides. So then I'm going to square root both sides. So then remember this is going to turn into absolute value here. And then I want to simplify root 8. So I'm going to just do that off to the side over here. So the square root of 8. So I'm going to do factors. So that would be 2 times 4 or 1 times 8. So root 2 times root 4 is root 8. I don't know the square root of 2, and then I know the square root of 4 is 2. So that would just be in the right order. So that would be the 2 comes first and then the radical 2, right? Just to get that in standard form. And then we're going to create 2 equations because it's an absolute value, right? And then normally we would have that negative over here, right? And then divide it over. But now we're just going to always just divide it over just automatically, okay? Because we had to do that over and over again on the other lesson. So we're just going to do that automatically. And then solve each equation. So then I would subtract 2, right? So this is just like the other objective. And then making sure we get this in the right order. So we want the negative 2 first. And then this is a positive, so we're going to put a plus. Keeping in mind I can't add those together, right? So these cannot add together, integer, irrational. And then I'm going to subtract 2 here. And then again, I can't combine these, so I want the integer first and then the irrational second. And then I can leave my answer like that, or if I recognize these are conjugates, I could write it as negative 2 plus or minus 2 root 2. Either way is acceptable. Okay. All right, so press pause and try number 2. See if you can do that on your own. And then forward to the right answer and see if you got the same thing. Okay. So step 1 is we want to isolate the squared term. So I need to get the x plus 4 squared by itself. So in order to do that, I need to move the 2 and the 4 over. So I don't want to add these together, right? These can't be added because it's not 2 plus 4, it's 4 is multiplying this, right? And so I want to solve. So solving meaning move everything, don't combine. So I want to move the 2 by subtracting it over to the other side. So I'm going to do that first. So that will give me 0. And so I will have 4 and then x plus 4 squared. And 18 minus 2 is 16. And then divide both sides by 4. So if you didn't press pause and you're just watching, press pause, try to do it, and then check. Okay, that's the only way you're going to be able to figure this stuff out. Okay, so now we're going to square root both sides because that's what step 2 says to do. This turns into absolute value. And then the square root of 4 is just 2. And then solving an absolute value equation, that's what we did on the other lesson. So I'm going to create 2 equations because this is a positive number. So that would be, my first one would be x plus 4 is equal to 2. And then my other one, this would be negative, the negative version, but we always divide that negative over. So we're just going to do that right off the get-go. So divide by that negative 2. And then solve each of those equations. So we're going to subtract 4. And then subtract 4. And so then I have x is equal to negative 6 and negative 2. Okay. All right. And this last little bit here is just kind of precursor to your quadratic equations, like solving for that. And so this is just kind of a reminder of how to simplify some of these radicals and just kind of practicing making sure we know order of operations. Okay, so if you think you remember, try it, and then just check your answers. Okay, so let's go ahead and do this. So there is nothing in the top that can combine, and then the bottom is already 4. So really we're just looking to see, like, can we divide anything out and simplify? So a lot of students want to just go 8 divided by 4 is 2, but this is a long division bar, right? So whenever we make a long division bar, then what does that mean? That means the 4 is not just for the 8, but it's also for this one here, right? That's why it's a long division bar. So then I'm just going to split this up. So this would be 8 is being divided by 4, And so is the 10 root 3, right? So both of those, that's another way I could have written it, right? Both are being divided by 4, so we use short division bars also, right? It means the same. So then if I reduce that, 8 divided by 4 is 2. And then here I can divide a 2 out of both of those, right? So I can divide a 2 out of the 10 and out of the 4. So I'm not trying to divide it into the radical because that can't simplify. So then 10 divided by 2 is 5, so that would be 5 root 3. And then 4 divided by 2 is 2. So that would be one way to simplify it. Another way is if you just take a look at all three of these, you could say, okay, is there something I can divide out of all of those? And I can divide everything, 8, 10, and 4 by 2. So an alternative way to do that is just divide a 2 out of everything, because all three are divisible by 2. So 8 divided by 2, 10 divided by 2, and 4 divided by 2. So that's another way, right? And both of these are accepted answers, right? This is just reduced, leaving it as a common division bar, and this one is reduced by splitting your division bar. And both are acceptable. All right, last problem here. This one's kind of a long lesson, huh? Okay, so for this one right here, so the first thing I want to do is my grouping symbols. So that means I need to simplify this and I need to simplify that, right? So that should always be the first thing we do is grouping symbols. So like gems, grouping, exponents, multiply, blah, blah, blah. Okay, so, all right, so here we go. So I still have 6 there, so that didn't go away. And then I'm going to do this right here. So negative 6 times itself is positive 36. And then here I'm going to multiply all three of these together. So I'm going to multiply negative 4 with 1 with negative 3. So negative 4 times 1 times negative 3. So I'm multiplying those three together. So that gives me a positive 12. And then 2 times 1. And then let's do that. So 36 plus 12. So I have that. And then I can simplify the 48, right? So the 48, again, so let's see, I think I did factors last time. So yeah, let me do a factor tree this time. So I'm going to just do it off to the side. So for 48, so that would be, what is that? 8 times 6, and then 4 times 2, 3 times 2, and then 2 times 2. And then I'm going to kind of cross off what I broke off. Okay. So then now look for pairs. So I have a pair of 2's here. And then, oops, okay. Okay, and then a pair of 2's here. So I have 2 pair of 2's. So that would be, what is that? So that would give me 6 plus or minus. So 2 pairs of 2, so that would be 2 times 2, so that would be 4. And then 3 does not have a pair. And then 2, okay? And so here again, I can do, you know, what will divide out of the integers. So what divides out of 6, 4, and 2. And I can divide all of those by 2. So let's go ahead and do that. So 6 divided by 2 is 3. 4 divided by 2. And then 2 divided by 2 is 1, but I don't need to put the over 1. Okay, and that's it.